Okay, we are live behind the scenes on the second floor at the American Precision Museum with director Steve D'Alessio. Hi, Steve.
How are we doing?
All right.
So we're going to be taking a walk through our back room here, our storage area. Some rarely seen objects. And the first one we're going to come to is this typewriter, Mion. If you remember the old days of the Selectrics, they had a ball that used to have characters around it, and you would type, and as it would type, it would move around and come up to the different characters unit. This is a Mion around, and that would give you the different letters and characters. And you can watch up here, you can watch as the mechanism turns. So this is a very early version of the Selectric typewriter that you all came to know and love in the...
How would it imprint on the paper?
The paper would be fed in through here, come up, and then there'd be other levers that would allow it to type down on it.
Oh.
So that's how that would work. So you'd move your probe over to your first letter, press down.
Oh.
Move over to the second letter, press down, and then this one would actually index the carriage over. So that's how that one would work. It's a beautiful piece. And if you look around over here, you'll see numerous other typewriters that some are covered up for the winter. But you'll be able to see how many more that we have in our collection. It's quite extensive.
And they don't see it necessarily,
But if you come back during the season, that'll allow you to come through again with more explanation.
Right.
The next object that we're going to come to is we have a fairly extensive collection of sewing machines that never get out on display. This is a very early industrial sewing machine. If you look down there, you can see the foot, and you can see the needle mechanism going up and down. This is a very early industrial version of a sewing machine.
Very early. Do you know approximately when?
I would say in the late 1800s, maybe.
Okay. And was this foot powered?
No, it wasn't. It was powered by either water or maybe a belt later on.
Okay.
We also have some other early versions of cabinet type sewing machines. This is another early version as well. This one is treadle powered from below.
I like that it's shaped like a butterfly. That's
shaped like a butterfly. Put two feet on it and pedal it away.
And does that tuck in? You fold the desk over? So...
Yes, it does. It'll fold back into the unit again.
I think my grandma had one of those.
Yes, you can see another version of one of.
Oh. Nice. So I recently read that one of the main engineers at Robbins and Lawrence. His brother. I read it somewhere.
All right. Another piece of machinery that we come up to is a gear cutter. It's a 24-inch gear cutter. It is a little bit of a mystery about this machine. It wasn't really manufactured until about 1910. However, this one seems to have been manufactured earlier than that. So we do have a bit of a mystery of why this number 59 machine exists. It's probably the 10th one built in the production line.
Because it has a serial number of 10?
No, it's number 59, which represented the 10th machine that was built.
Okay.
And this one was built...
Well, here's the tag that says Mystery Gear Shaper.
Yep.
Hello.
This was built by Fellows Gear Shaper in Windsor, Vermont.
This one?
Yes. So this is kind of a local piece. It's quite unique and quite large.
So, show me how it would kind of work.
So if you had a blank round disc of steel placed on the machine, this cutter would go up and down while this was turning, and you'd get each tooth cut as it goes around.
Okay, so it would cut giant gears like this one.
Giant ones, yes, big ones, large diameter gears. We have a working version of one of these down in our innovation station that'll be up and running, but it only makes very small gears.
Right.
A very similar machine.
Tell me about the innovation station for a moment.
Our innovation station during the summer is manned by some summer interns, high school students typically. We have several machines that are running down there, including a brand new Haas CNC with a Mitaco pallet changer on it. We'll be making some puzzles this summer. that people will be able to get in our gift shop or get one free in the Innovation Station. We also have a gear cutter that goes back to 1940 that'll be cutting gears much smaller than this, obviously.
Actually in action. Right?
Actually in action, along with a turret lathe where our interns will be making goblets on a machine from the early 1900s.
Now, are we still looking for high school interns, basically?
We will be, depending on what happens with the season.
Right.
The next machine that's kind of really interesting.
Oh, I like this one.
This is a framing square.
Mm-hmm.
And on the framing square, you'll see all these little scribe marks that go up and down along the whole length. This machine actually cuts all of them at one time. The framing square would be laid into the machine, clamped down, and then the machine would go forward and back. And each one of these positions is a different scribe line on the framing square. And this goes, again, very early. Again, this goes probably at least into the 1900s.
Can you tell me what the framing square itself was used for?
It was a carpenter square used for setting the frames on housing.
That's kind of what it sounds like, right?
And walls, things like that.
So what I think is interesting about this is once you have one of these, does it have to be, is this machine pre-calibrated or?
Yes, it was all set up with, once these scribes were placed in position, they wouldn't be moved.
Right.
So that once it was set up, it would be repeatable. Again, the whole theme of the American Precision Museum is about reproducible manufacturing and repeatable manufacturing.
Right.
For all about interchangeability and interchanging parts.
Right. And that's, I think, when you have something like a ruler where it should be exactly the same every time, the fact
that nothing moves other than forward and backwards.
Yeah.
Really
you know you're getting the
difference.
same.
So that was a machine that was created. It was a early machine, for sure.
And Steve, I kept saying we should bring this down for the measurement exhibit, but it's really, really big.
Really big and really heavy.
Right. So maybe we'll do another video just on this guy here.
Yeah, this is a water-powered machine, too. So
cool. So that's the where the belt would go?
Where the belts would go.
All right. And why is it so huge?
It's just big and heavy.
All right.
Mostly for stability. If you're going to do things that are precise, you want things to be stable.
Oh, much like the granite bed lathe and the Blanchard.
And all those kinds of things.
Right.
Another interesting machine is over here. This is for cutting the pocket of a revolver. There are two cutters, one on either side, and the cutters would move in and cut and come out again.
Okay, I see one of the cutters there.
You see one cutter, and then there's another one in the back. And they would move in and out, and that would allow them to cut the pocket very accurately on a revolver.
Nice.
See that turn.
And I think, viewers, if you have any questions, please feel free to send them along. I'm not seeing any yet, but maybe we're just doing a great job of explaining.
That's always good. Most machines that were in the 1800s were built for specific purposes, and you can see another example of that behind here. It's a very tall lathe with a faceplate on it. So again, it was probably made and built for something very specific, something large in diameter.
So this is doing the pocket of the revolver, this guy right here.
This guy is doing the pocket of the revolver.
Okay.
Yeah. It would move back and forth with a slide here. This would be the slide that would move it back and forth into the cutters.
Excellent.
Okay. Another early piece, this is a steam engine for a two-cylinder steam engine.
It has a bit of an anachronism on it, right? The tennis ball.
Oh, the tennis ball, yes. To protect our legs when we walk around.
Right.
But anyway, this is a two-cylinder steam engine that would be probably on a boat. It has a horizontal shaft running through it.
It's a different shape from some of the other ones that we've seen.
Yes, some of them are smaller, some of them are bigger. We have an example here of a horizontal milling machine. Again, very early, belt-driven machine. Horizontal being that the spindle is horizontal rather than vertical, and it moves back, and the table moves back and forth and front to back. With a single cutter in this case. Usually they gang cutters up, 2 or 3, 4 cutters in a row.
So is this one that would be more customizable sorry. You mentioned that those were specific machines.
This would be more of a machine for a job shop that does different types of parts.
Right.
It would be constantly taken apart and set up again and be done. The large piece in the back is a tensile strength machine for measuring the strength of materials.
Looks like a popcorn maker, but I think I can see. This was one that was on the measurement exhibit from 2003. I saw the description there.
Yes.
So it's got like a
scale on top for putting different weights down, and then it would try to pull the material apart.
Wow. Okay.
So and you'd measure the braking force. This is another good example of an engraver, of a very early engraver. Not quite as early as some of the other ones we have, but again, they put the material down here and they'd be engraving with these points, whether it be a scale or whether it be another piece of measuring equipment.
Okay, I think I see. It's got a light bulb. It's got a stylus there.
The light bulb is telling us that it was along the way a little bit.
Right, maybe after 1880s, right?
Well into the 1900s.
And
this
does it
was
have
already electrified all the way around.
An indexing thing over here?
Yeah, this is an indexing wheel, and this is another indexing wheel that allow the table to be precisely moved in different directions for the etching to take place.
Got it. I feel like it would be hard to do letters with that, but if you were doing something else.
Yeah, we'll come back. There might be another machine around that does more of a lettering.
Okay, cool.
Again, these are traditional lathes. It was a belt-driven lathe, geared for lots of different things, for threading as well. So that was another older machine.
And where would the belt go around this center?
This centerpiece in here. Yeah, this would be the belt.
This one is J. Birkenhead from Massachusetts.
Yeah.
Do you know what the rest of this means?
These are for different thread pitches.
Oh, okay.
So if you were cutting a screw or a bolt or a lead screw, you would set it to the different pitches so that when the tool comes across, it's going at the right speed and feed for that thread.
Got it.
This is a
I like this one.
Rifling machine, a hand-operated rifling machine. All you gun enthusiasts out there, you'll know that there's rifling inside your barrel that causes the bullet to spiral out.
You know, my analogy for that is always just like throwing a football spiral. It goes straighter and faster.
It goes straight and faster, right. So this is a very early version. Again, this one is mid-19th century. It was done by hand. And again, it's a beautiful example of the detail that they put into machines along that way. But this one was done by hand to put that rifling in there. You'd probably be turning the handle, and as you're turning the handle, it would be turning the tool. It's causing the spiral as you move through the barrel.
Nice. Okay.
So come around.
Oh, we're going this way.
Oh yeah, we'll keep walking this way, I guess. We have another early version of a treadle version of a sewing machine.
I have a good question. Why do we have so many typewriters and sewing machines?
Well, at the end of the war, when you're done building rifles and guns, you have to do something else with your factory. So, but at that time, once the Civil War was over and people started thinking about the consumer culture, where people were looking for kitchen gadgets, sewing machines, typewriters to help them all save time in their life. So the sewing machines, of course, took away a lot of the hand sewing that was taking place. So that's why this factory was converted over those years.
Because they already had the machines and
the process and the method.
Right, and there was less demand for the particular parts that they were making.
Right, so they just switched over their machinery and their process to make consumer goods. We come around again, is another version of an engraving machine.
Oh, that looks very different from the other one.
Some interesting things. It's very large. It's circular. Again, you would be able to drop down the engraving probe and start doing circular measurement or circular graduations on things, maybe to build a protractor or in those kinds of examples.
I saw there's a 1890s Brown and Sharp protractor on exhibit prep.
On exhibit, that'll be out on exhibit.
Yep.
One of my favorite machines in this place is this universal machine. It's a lathe, drill press, and milling machine all in one. most likely you'd see these on battleships.
Oh,
where
wow.
they needed a lot of machine tools and they didn't have a lot of space. So they created these universal machines. It's in an excellent condition. It holds collets.
This one's a Gilman, right?
Yes.
I think I use a picture of this one for a lot of our marketing materials because it's a nice looking machine.
Yes.
Which
pristine.
Different elements of the machine do different processes, right?
Yes, this part of it is a lathe. On this end, this could be used as a vertical milling machine or a drill press. This side was a horizontal mill. It's equipped with a indexing head. This 3-axis on this side, vertical axis on this side, and cut threads just like we saw on that other machine with almost lots of different options. Again, it had the ability to put a center out so you could put longer parts in. Quite a unique machine.
So I see a little, looks like a fuel door down there. What kind of power did this one run on?
This is electric.
Okay.
Yeah.
Oh, so that's just kind of a storage cabinet.
Yeah, it's storage or a way to get to motors and things like that.
Got it. Oh, I see something cool
Also
over here.
had power feed on it, which was kind of nice as well.
Are you going to show me an electricity thing in a moment?
We're going that way, yes.
All right.
We're going around. So we have some other unique pieces here. This is part of our measurement exhibit. This is a watt meter from General Electric. So it's quite beautiful and quite detailed.
Well, I think what's special about this one is that wasn't this one Edison's personal?
We believe it came from Edison's lab. Yes.
Right. And that's why it looks so pretty, because it was maybe commemorative or something like that.
Could be, yeah. That's the provenance that we have on it at this point. We have a engine pump back here for pumping water.
Oh, would that be used for fire trucks?
I doubt it, but we certainly could be used for numbers of different things.
Okay.
This is another specialized lathe that was built.
Yeah.
We have machines like this. This is a profile mill where a probe would follow a pattern and then force the cutter to take those paths.
Oh, let's talk a minute about patterns and profiling and repeatability.
Well, we've moved prior to about the 1800s, maybe 1820s, things were done with hammers and anvils and files and saws and things like that, carvings. As we move forward, in order to get repeatable manufacturing and reproducible manufacturings, the craftsmen at the time made a metal pattern. And that pattern, the machines would follow those patterns. So part after part would come out the same way. So profiling was just one way of doing that. These probes would follow a metal pattern and the cutter would go along on the part that would be manufactured.
Right.
So another interesting piece while we're here, this is a piece of soapstone that was actually threaded. We're not sure of its use.
And it goes in
and
there,
it goes
right?
into this one here, into this post. So we're thinking that this may have been some sort of a water system at some point in time, but these are just big plugs that went into the end of them, but they were threaded. But it is unique that it is a stone where they've cut the threading.
Excellent. This one behind us is interesting.
This big one here is a power press. We have a small one that's on display and working in the innovation station that uses to put an impression down. It's used for forming steel or forming aluminum or whatever material into a shape. It's kinetic energy. The wheel would be spinning, building up energy, and then it would be suddenly released and then turn to go down. Right into
I know in modern shops you can kind of hear it. The stamping press is going ka-chunk, ka-chunk,
yes,
ka-chunk.
ka-chunk, ka-chunk, right? That's it. This is a key setting machine, very large keys. But if you look into typically a gear or a pulley, there's a groove that's cut down into there so that a keyway can fit into there. That would go match up with a shaft, and that would prevent the gear or the pulley from slipping on the shaft. And this machine is a very large example
Great.
of a key cutter.
I can't, unfortunately, check the time because I'm using my phone. I don't know how we're doing, but...
Anyway, we'll keep going real quick. Right. This is a dynamo. It's a real early version of a dynamo used for electric motors, but it's a very early example of one.
Oh gosh, it looks like one of those bugs that rolls up. But can you explain a little bit more
It's
what
part
a
of
dynamo
magnetic
is?
Field. It's a magnetic field, and it's been spinning.
Okay.
And it's just
Like
actually the
electromagnets
internal
and stuff.
part of the electromagnet assembly. Yeah.
And then this guy right in front of your foot, I posted on April Fool's Day.
This is like April Fool's Day. This is our etheric force machine.
Right.
It was built by a gentleman named Keeley, who thought that vibration could create a force.
So,
But it's probably one of two. We believe it's the only one that's in public view right now. The other one is in the hands of a private collector somewhere.
from what I understand, he made about 2,000 at one point, and they would something like it was actually powered by connected to an air compressor, so it would blast, so you would have some kind of sensation.
Essentially, it was a scam.
Yeah.
He kept, it was a pyramid scheme. He kept asking for more money. I'm getting closer. And as people invested, and then eventually they figured it out.
Right.
It wasn't going anywhere. This here is a ballistic chronograph, and this will be on display in our measurement exhibit coming up when we open. It's used for measuring the speed of bullets.
I was working on the exhibit labels and trying to understand how it worked, and
There's
I think
two-
I know.
Yep, there's
Yep.
two metal screens, and when the bullet passed through those metal screens, it would be able to allow a point to be made, and then the distance and the speed and time.
Yep, distance divided by speed equals time. Did I get that one right? Is it the other way?
The other way, yes.
Yeah, okay.
So you have a bunch of meters out here. These are, again, all various forms of voltmeters and amp meters made by different companies.
So can we talk for a moment about this space and why it looks like we're in an attic and why there's so much stuff?
Well, over the years, over the 50 plus years that the museum has been in existence, things come to us.
Right. And we already started with quite a few items.
The founder of the museum, Ed Battison, was quite a collector, and a lot of these objects were already here. He founded this, when this building was going to be torn down.
I found that he was already using the space for storage.
He purchased it, and this became the American Precision Museum.
Right.
It's on the National Historic Landmark. But this is only a small portion of his collection. There's another museum just behind us that's not open to the public that contains the rest of his collection, which is just about as much stuff as you see here, if not more.
Right. So it's safe to say that we're not actively pursuing new items at this time, and that this is a behind-the-scenes area because none of this is really prepared. It doesn't look nice for visitors, but it's still interesting stuff.
It's still really interesting, and
it's cold up here.
We are still collecting objects, but they're very specific. Things that are unique to this building or are unique to the area, we still consider for the collection. But we're getting a little bit, as you can see, we're running out of space, and we're trying to keep a good handle on our collection right now. The other end of this tour here is we have some scales that will also be out on display.
Oh, good.
In our measurement exhibit, some very early types of scales, some very early ones here as well.
Let's see if I can. Oh, there's the flash.
Yep.
Yeah. One of these is some kind of automatic scale, and I don't know.
Perhaps this one.
Okay.
They're all unique in different time eras as they go along.
Right, and they're IBM, right? Early IBM.
IBMs, maybe. Yeah.
International Business Connection. That's all right.
And then we also have way back there, a grinding wheel.
Okay.
So as
The treadle.
yep,
Okay.
this will also be out on display when we open up in the season
Oh, great.
as part of a little revamping of our grinding area.
So, I was going to say that we were planning on opening May 1st.
We were planning on opening May 1st. Of course, we don't know when we will be opening yet, but hopefully by the end of May we'll all be up and running again.
Yep. And we normally open Memorial Day anyway.
Anyway, so we tried to move it back 4 weeks this year. Unfortunately, the COVID-19 pandemic kind of set those plans
Right.
in motion a different way.
And in the meantime, I am keeping 6 feet away from you,
Yep.
and people are working from home at the museum.
And we're all trying to do different things.
Right. Yes.
We welcome you again to the American Precision Museum. I hope you come back. Keep looking at our website, americanprecision.org, for the latest opening date, and to keep in touch.
Thanks,
Take care
Steve.
now.